So your second unit is a transistor, and so transistor. So in a transistor, we are going to see the first type of transistor is bipolar junction transistor. Okay, so what is a bipolar junction transistor means? The conduction will be happened by the both, whether it may be a electrons or it may be a holes. So based upon the type of your transistor which we are using, so that's why it is represented as bipolar transistor. If you use some other transistor will be there, it will be unipolar. So unipolar means only the electrons will be do the conduction, or otherwise the holes will be do the conduction. Any one will be do the conduction, but here the electrons and then holes, the both will do the conduction. So that's why it is represented as bipolar junction transistor. Okay, so like a diode, we may have a two layer with one junction, and here we having a three layer and with the two junction, and for the three layer we are connecting one terminal, so that are named as emitter base collector. And here they will use the three layers is nothing but the n type and p type, so both will be combined, recombined. So it may be a n-p-n combination, otherwise it may be a p-n-p combination. So two types of combination will be there. So the bipolar junction transistor will be classified into two types. So one is the NPN transistor and another one is nothing but PNP transistor. So the combination, like I said, so NPN means the N type first will be there, and central layer will be P type, and the last one will be a N type. So like how the diode junctions are made. So P type they will take and N type they will take, they will attach together. Similarly here, three layers, so we may get two junctions. Okay, and if you go for another types, the PNP, so first layer will be a P type, and second layer will be a N type, and third layer will be a again a P type. Okay, so these are the two classifications of your BJT. So here you can able to see the structure, like I said. So first one is a NPN transistor. Um, so this is your NPN transistor, and this is your PNP transistor. So like a normal diode, how the two diodes are connected back to back. Similarly here also available. So if I take this one, so N and P, so this is one type of diode, and here PN, so this is another diode which is connected back to back. Okay, so that it will create like a transistor structure. So here also it is same, and most preferably in most of the electronic circuit they will use n type npn, I mean npn transistor only. So why? Because here the major roles are done by the n. So two layers are n type and only single layers are p type, and n having a majority of electrons. So here the conduction will occur due to the electrons only, and the electrons mobility, the movement will be very faster, so the current flow will be very faster. So for high switching operation we will use, I mean high means very fast switching operation, so we will use the n type. So if you go for the p and p, here the conduction will occur due to the holes only, not electrons. Okay, so due the holes having less mobility when compared to your n type. So holes always will be having a less mobility when compared to your electron. So the speed of operation will be less when compared to that NPN transistor. So that's why always the NPN transistor will be used in most of the electronic circuits. Okay. So here it's a three-terminal device. One is nothing but an emitter, and center is nothing but the base, and the last one is nothing but the collector. So these are the three terminals which the named for the emitter for the bipolar transistor. And why it is called as emitter base collector? In a diode we named it as anode and cathode. So based upon that, anode is representing the positive charges, and cathode is representing the negative charges. And here we are representing using the collector, base, and then emitter. So what is the reason? So let's see. Here the emitter will be there. So what it will do in the sense, it will have lot of electrons, so the doping concentration is very higher. And what is the function of the emitter? In the sense, it will emit the electrons. So how much electrons is available, it will emit the electrons towards the base. Okay, and if you see the collector, so collector used to collect the electrons from the base. So that's why it is named as a collector. So emitter used to emit the charges. So charges is nothing but suppose if it is a NPN transistor, it will emit the electrons, and the collector used to collect the charges. So electrons I will collect, and the base will act as common for both the collector and emitter. So without that we cannot able to make the conduction. So suppose if only two layer means it will be like a PN junction diode. So that's why it is the middle one. So which is connector, that is represented as a base. So this is the transistor how it will be look like in real. So having the three terminals. So first one is nothing but your emitter, and the middle one is a base, and the third pin is nothing but your collectors. And this is the transistor symbol. So having the three pins. So emitter and base, collector, and the structure will be like this. So this is the base. In a base, the collector is attached, and then the emitter is attached, and you can able to see some small arrow mark will be there. So it represents the current flow. So, and we can able to identify using that arrow mark whether it is a NPN transistor or a PNP transistor. If the arrow mark is outside means it is a NPN transistor. Suppose if it is a PNP means it will be like this. So a normal base will be there, and the collector will be there, and the emitter will be there, and the thing is the arrow mark will be here. So it represents the current flow will occur from emitter to collector. So this is the base, and this is your collector, and this is your emitter. So current flow will be like this. But here, if you note it down, the arrow mark in this direction, so that the current flow will be from upwards to downwards. It representing the current flow will come from collector to the base to the emitter. But if you go for the PNP transistor, actually this is a PNP. So in a PNP transistor, the arrow mark will be indicate in opposite direction. It represents the current flow will be in opposite direction. So that is the difference between the NPN and PNP transistor. And like I said, so why it is named as the emitter? The section of one side that supplies the carriers is called emitter. So supply represent emitting. So carrier represent whether if it is a N type, it will emit the electrons. If it is a P type, it is emit the holes. So that's why they represent carriers instead of the electrons or holes. And for a conduction, we will use the emitter base junction as a forward bias, and the collector base junction in reverse bias, in order to make the transistor function properly. Okay, so that is the main thing. So always keep on remember. So in order to make the transistor, actually various application is there. So transistor will act as an amplifier. A transistor will act as a switch on and switch off. Okay, so here usually the transistor, the emitter base will be always be a forward bias, and the collector base will be a always be a reverse bias. Okay, and here the collector. So like I said, the section on the other side that collects the carriers is called collector. So if it is a N type, I mean NPN transistor, the collector will collect the electrons. Okay, and the collector base junction always will be a reverse bias, and the base. So this is the middle section which will act as the base for the emitter and then collector. So that's why it is named as a base. And now they are telling some few points. So how the doping concentration will be. So here I told emitter used to emit huge number of electrons. So in the sense emitter need a huge number of electrons, right, in order to emit it. So what I will do in the sense I will do doping concentration will be very high. If the doping concentration very high, in the sense huge number of free electrons will be available in the emitter. Okay, and base are lightly doped, and the size of the base is also very thin. Why? Because it doesn't want to hold much charges. Just it will act as a base for the collector and then emitter. Okay, so that's why the base are very lightly doped and the size of the base also very small, and the collector are moderately doped. So it is not lightly doped and it is not heavily doped when compared to that. So thing is, emitter is heavily doped so that it will emit a huge number of electrons. If it is a p-type, it will emit huge number of holes. Okay, and the base is lightly doped and the size of the base also very thin, and the collector are moderately doped when compared to the emitter and then base. Okay, and so far you have any doubt about the transistor? Do you have any doubt, guys?
No, sir.
Yeah. So just recalling, so transistor is a third terminal device. So the classification will be two types. It may be a NPN transistor or it may be a PN transistor. And emitter is used to emit the charges, and collector used to collect the charges. Okay, and NPN transistor, the current conduction will be occur due to majority of electrons, and the PNP transistor, if you are using, the conduction will be occur due to majority charges like a holes. So the electrons also used to conduct, the holes also we are using to conduct. So that's why it is named as bipolar. So polarity, so polarity represents positive and negative. The electrons are negative and holes are positive. So we are making the current conduction using both the charges. That's why it is named as bipolar junction transistor. Okay, and and also we seen the current direction. So if it is the n type, I mean NPN transistor, the conduction will occur and current flow will occur from collector, base and emitter. If it is the PNP transistor, means the conduction will occur from, I mean the current flow will occur from emitter to base to the collector. Okay, so that is a different. And let's see the operation of the transistor. Okay, so here they are just drawing. So this is your uh, and here it is the emitter. I will draw. So it is having more number of electrons, so due to more doping. And this is your base. So base is having less doped and the size of the base should be very less. And this is your collector. It's moderately doped. It's used to collect the charges. And this is the NPN transistor. So majority will be electrons in the emitter as well as the collector. The majority will be electrons. And like I said, so I used to tell. So the emitter base junction will be forward bias and the collector base junction should be reverse bias. Okay. So here I am drawing. It should be a forward bias. Emitter base forward bias, and collector base should be your reverse bias. So if it is a forward bias and this is a NPN transistor, I will draw. This is a N type and this is your P type and this is your N type. So I want to give a forward bias means, so in this junction, actually this is the junction, right? So this is one junction and this is the another junction. So I'm representing the emitter base junction. So emitter base junction should be forward bias. So that here the base is having a P type and emitter is having the N type. So what how I want to connect the battery, external battery. So P should be connected to your positive and then the N should be connected to your the negative terminal of your battery. So that then only it will become a forward bias condition. And if you go for the another junction, so another junction is collector base junction. So in a collector base junction, if I am giving I want to give a reverse bias, means the P I want to connect it to your negative. So that's why I connected to the negative of the terminal of the battery, and the N type. So N type is nothing but the collector. So that is I connected to your positive terminal of the battery. So then it will act as a reverse bias condition. Okay, so all of it clear about this? And now let's see the operation. So once I'm giving the forward bias condition, here I'm giving a more negative charge to that N type. So N type having a huge number of electrons. So electrons are negatively charged, and here also I am giving the negatively charged. So it will repulse each other. So what it will do, the electron will start to cross the junction. So once it is crossing the junction, first junction, base is very thin and it is lightly doped. So very few holes will be there, free holes, so that the combination will be very less. For example, the emitter will emit 100 electrons. I am telling 100 electrons in the sense, in a base it will take 1 or 2 electrons only, and remaining electrons it cannot able to go. So why? Because in a base I am giving here plus, but if you see here I am giving more negative to the base. So here also I am giving negative. So the electrons cannot able to come in this direction. So the electrons cannot able to come in this direction. Only way to move the electron is to cross the another junction. So thing is, from the electrons from the emitter will cross the junction, first junction, and very few electrons will recombine with the base, and after the majority of the electrons will cross the collector. So that is the operation exactly. So let me play the animation. So electron is coming, and you can able to see the yellow color indicating it is recombining. So very few electrons become recombined, and remaining all electrons are moving towards the collector. So thing is, this is how the electrons start to flow. So emitter is also having the current flow, and the collector also having the current flow. So if you look at this, you know that if it is a path, in the sense the current will circulate entire circuit. So the current flow will be done in entire circuit. So thing is, here the electrons start to flow, and then it is crossing the first junction, and again it is crossing the second junction. It's crossed the collector, and due to here positive charge, the electrons is attracted and coming out. So likewise it is coming in this way, and again it get back from here. So this will create a complete path of for the current. So this is how the current flow will occur. So thing is, electron is flowing one direction, means current will be flowing another direction. So how the current flow will be? So listen, the electrons flow. I will write the electrons is flowing in this direction, right? So how the current flow will be? So current flow will be in opposite direction. So I will write the current flow like this. So current flow will be in opposite direction. So what is the net current? IE. So IE is nothing but the combination of the current from the base and then the current from the collector. So that's why I represent IE is equal to IC plus IB. So IE represent the emitter current is equal to the collector current addition to your base current. So base current is very small. So sometimes I will neglect the base current also. Why? Because it's the electron flow will be very less when compared to your collector current. See, it's the first, for example, the current is 100% in the sense the base current will be only 1%. So that's why I represented in terms of 100. Suppose 100 electrons are crossing in the sense only one electron will be absorbed by the base, and remaining all will cross the collector. So if I talking in terms of current, means the current which is crossing. So if it is entire overall current is 100, in the sense, suppose IE is 100 milliamps, means the IC will be 99 milliamps and IB will be 1 milliamps. All of it clear about the current?
sir.
Yeah. So in a circuit, total current is equal to the current which is divided in many um, interconnection, right? So if you do any circuit analysis, if it is having more number of loop, in the sense the total current will be equal to your the current which is occurred in each and every loop. So likewise here also the total current is nothing but IE is equal to combination of your first loop and I mean the current which is flowing through the collector as well as the current flowing through the emitter. Okay, so that's why I represent IE is equal to IC plus IB. Okay, so likewise the electron will start to flow, so current will be in here. So here also they are representing using that current. So listen here, if the emitter current is 100% in the sense, I mean for example 100 milliamps means the collector current will be 99 and the base will be a 1%, very less. Okay, so based upon this ratio they will calculate the uh, beta. So beta represent amplification factor. So how much it is amplifying. So like I said, initially I told transistor will act as an amplifier. Okay, so amplifier, what is an amplifier, ma? What is an amplifier? Guys, what is an amplifier? Are you people using amplifier? Yes or no? Just respond.
No, sir.
No, you people are not using amplifier in your life. How many of you are having a home theater and that sound box 5.1 channel, 2.1 channel? Hmm? How many of you using it? And how many of you increasing the volume in your TV? How many of you connecting your mobile phones into the speaker and playing? How it is happening?
Frequency.
If you are connecting your headphone in your mobile, you can able to listen the music in high volume or low volume when compared to playing in a speaker. So thing is, the signal which is generating in your mobile phones, it will be in terms of milliamps. So that very small speaker will work under that. So for example, that is your headphones. So you're using headphones having a small speaker only. Suppose if you connected directly a big speaker, it won't provide that much output. It represents the signal strength is very less. So we required an amplifier. So you are using that sound speaker, right? The speakers. So and 5.1 home theater. So everything inside that is nothing but an amplifier. So it will improve the strength. So improve the strength in order to drive the output devices. So if you are connecting a very huge speakers, so that is nothing but your device. So output device. So if I want to make it work, I want to give the particular input voltage. Suppose it is working. For example, mobile phone generating 10 milliwatt. Okay, and I'm connecting the speaker which is will be worked in 100 milliwatt. It's not sufficient. If you connect it, it will play with a very less volume. So in order to boost it, in order to boost or in order to amplify, I required amplifier circuit. So inside the amplifier, there will be a transistor. So that is the major application of the transistor. Okay, so what it will do in the sense, it will give, if you are giving a small input, it will boost up, it will improve or it will strengthen the signal. After that, it will provide the output with high voltage. So that is the main application of your transistor. Okay, so now tell me, are you using amplifier, all of you? Are you using an amplifier?
Yes.
So not only the speakers, even inside the TV also amplifier will be there. Inside the mobile also amplifier will be there. So if you connect to the headphone, you can able to listen. But if you're removing, so if it want to play with the mobile speaker, it requires a small circuit. So that is an amplifier circuit. So based upon the size of your speaker, the size of the circuit will vary. If some people, I mean the DJs and all, they will have the huge speakers, and if you see, the amplifier box will be very much huge one. Okay, so based upon the output it is driving, the size of the circuit will vary. Okay, so here the beta represent amplification factor. So listen, so base, using the base I will give the input, and after that if you check it, if I will connect to that DC voltage to the collector, I'm getting the more current. Actual thing is likewise only. So base input is very less, and the collector output is very high, emitter output is very high. So amplification factor, the beta represent amplification factor, is nothing but the ratio of collector current to the base current. How much collector current I am having, how much base current. So base current is nothing but your input. So that beta is equal to IC by IB. Otherwise, IC is equal to beta into IB. So this is the main formula you have to remember. Okay. So like I said previously, so suppose, yeah, so collector current is 99 milliamps, means base current is 1 milliamps. Now what will be your amplification factor? So it is equal to 99, right? Exactly. Is it right or not? See, milliamps get cancel each other. So beta is equal to 99. There is no unit. Okay. So this is the operation. All of you understood about the operation? Yes, sir. Okay. So this is the operation of your transistor, and just I'm given the operation in terms of slide. So this is your emitter. So this is your emitter, and this is your collector, and this is the base. So emitter base I connected in forward bias, and that is represented as VEB, and the collector base is reverse bias, so I am giving VCB, collector base voltage at collector base voltage. Always the collector base voltage should be very high when compared to the emitter base voltage. So that's why here I am using multiple plus minus symbol. Here only one, I mean here it should be very less when compared to here. Okay, so once I given, and due to that, see, this is a N type, and this is a P type, and this is also N type. So N having majority of holes, so these are holes. So here I am giving negative. So what it will do, it will try to push the electrons which is available in the N. So what it will do, it will try to cross the base, and it is crossing the collector. So very few are become recombined here, and from here very few number of electrons will come out, only one I told. So here 100 are crossing in the first junction, and one electron is moving in this direction, and remaining 99 electrons are moving in another direction. For an example I am telling in terms of number. Okay, so after that the 99 electrons are coming in this way, and here the one electron from the base and the 19 electron from here, it will combine and again become 100. So again here it is pushing in this direction. So as long as you are keeping the voltage, the electron will keep on flow, so it represents the current flow. So current flow will be in opposite direction in this way. So now I will tell the current value. So here emitter current is nothing but 100 milliamps. So 100 milliamps it is flowing. So that here how much in this direction, 1 milliamps will flow, 1 milliamps, and in this direction 99 milliamps. So that the total current become equal, right? So here it is 100 milliamps and coming in this way direction, and here it is dividing. Why? Because only one electron is coming in this opposite direction. So only 1 milliamps is flowing in this direction, and remaining 99 milliamps flowing in this direction. So and coming in here, and inside the transistor, once it is crossing inside it, 99 coming from collector and 1 coming from base, combined together 100 milliamps is crossing here and coming to your emitter. So now you understood that the total current IE is equal to IB plus IC. Okay, clear all of you? And now we will see the working principle of PNP transistor. So in an NPN transistor, I told the conduction will occur due to the electrons, but here in PNP the conduction will occur due to the holes. So that's why here you can able to see I drawn a holes. So it hits the NPN transistor. Here there is no holes, only electrons is there. So electrons are specified using the dot, and here the holes are specified using the circle. So inside it is not shaded, so they kept empty in order to make the difference electrons and holes. Okay, and if you see here, I told that the electron emitter base should be in forward bias. So emitter base junction should be in forward bias. Here it is P and here it is N. So forward bias means P should be connected to positive, N should be connected to negative. So what I am doing, so P is connected to your positive and N is connected to your negative. So positives are connecting here, as well as P is having huge number of holes. So hole will now try to move, try to cross the junction. Okay, and once it is crossing the junction, very few electrons which is available in the base will recombine, and remaining 99 percentage of holes will cross the another junction towards the collector. And here it is already in reverse bias condition. Here I am providing the negative voltage, and the holes are coming here, and it will attract by this negative voltage so that it will come out. And if you see here, it is representing the electrons direction, and inside the transistor they represent the hole direction. Okay, so don't get confused. So these are hole direction and these are electron direction. Okay, and it is quite opposite to the NPN transistor, so the current flow will be in this direction from here. So from the emitter it will go to that collector and to the base. Okay, so this is the actual current flow of your PNP transistor. So what are the procedure you studied in a NPN transistor? In a PNP you want to write in quite opposite manner. So in a NPN transistor you are writing the current flow will occur due to the electrons. In a PNP transistor it should be occur using the holes. And if you see the direction in a NPN transistor, it will be like output current will get from the emitter, but here the output current is getting from the collector. Okay, so like quite opposite in nature. So that is the difference between your NPN and PNP transistor. So these are the working principle, and if you see here the current direction is they are representing. So it is from IC will be coming in this direction and IB will be coming in this direction, and total current IE is equal to IB plus IC. So if you look at here, IC is equal to IE minus IB, quite opposite manner. Okay, so and like I said, the arrow mark representing the current flow. So here at the PNP is quite opposite. Okay, so the current flow will occur from the emitter current, from emitter to your collector. But if you go for the NPN transistor, it will be from collector to emitter. Okay, so this is the transistor symbol, and this is how the connection will be made in order to explain the operation of your transistor. And why it is named as a transistor? Actually, it's a combination of transfer resistor. Okay, so transfer resistor in the sense, if you observe that initially the electron is moving from the emitter, so huge number of electrons will be there, After you're giving a apply voltage, that electrons is moving to base and towards the collector. So thing is, if free electron is moving, in the sense the resistance are changing. Is it right or not? Actually, conductor means having a huge number of free electrons. So conductor is having less resistivity. If it is an insulator, there is no free electrons. It represents the conduction cannot be happen in an insulator. So free electron is not there, means the resistance is high or low in an insulator. Anyone? Insulator, what is the resistance for the insulator? Whether high or low? What is the resistance for an insulator? High or low?
Right.
High. So that's why there is no conduction. If resistance is less, conduction will occur. For example, conductor. Okay. Here, initially, the electron will be more in emitter, and after you are giving the proper voltage, the electron will start to flow to the collector, so that the resistance are changing from one layer to another layer. So that's why it is they representing transferring the resistance. So transfer resistance, they named it as a transistor. Okay. So if you look at here, sorry. So transfer resistor. So trans they taken from first, and the last part they taken, so that they combined together. They named it as a transistor. Well, if you clear why it is named as transistor. So actually, first we studied why the terminal is named emitter, base, collector. What is the reason we studied? Right now we are checking why they named as a transistor. So it represents the transfer the resistor. So if you clear. And operating mode, so there are three types of operating modes are there. One is the active mode, and second is saturation mode, and third is cutoff mode. Okay. And so during cutoff mode, the both the junction, so both the junction means emitter base and collector base, so should be in reverse bias. In a saturation mode, base emitter should be in forward bias, and base collector should be in uh, forward bias. And active mode, in the sense, right now we seen in active mode, so emitter base junction is in forward bias, collector base junction is in reverse bias. Okay. And we will see what is the active mode, what is the saturation mode, and what is the cutoff mode, and where, in which application we are using these three kind of modes of operation. Okay, that we will see. Active mode, first take a active mode. The active mode mostly they will use in amplifier circuit. Okay. So active mode, in the sense, it will do the amplification process. And saturation mode means like on switch. Okay. So and cutoff mode means off switch. So that's why both the junction should be in reverse bias, and if it is on switch, in the sense, the both the emitter base junction and collector base junction should be in forward bias. Well, if you clear about this, any doubts is there? Do you have any doubt?
No, sir.